So we'll have a look at this one now, and let's get rid of the answer and then build it up from scratch. Okay, here's the data, double click, and this has simply come out of a spreadsheet, and there it is. So this is the height of the water at certain times of the day. So there's high tide, there's low tide. What we want to do is to fit a trig function to this. So right click, enter equation. Now our two variables are h and t. So it's h equals a sine b sine t minus, now I'm going to use another variable, phi, because it's a sort of angle type expression, and then needs two brackets plus d. So this is the most general sine wave you can get, and notice the form for it. I personally think that bt plus phi, which people often use, isn't very appropriate because b and phi are independently interpreted. B is the frequency and phi is the phase. So we'll stick that in. At the moment all the values are 1, and that'll probably be right, so let's stick it in for now to see what we get. Now we're in radians, and that's a trig function, so that's its amplitude and so on. So what you could do is select that, and right click and say, look, I want to do a Bestfit data, thank you very much, and it'll just give you the answer. I think from an educational point of view, it's much better if we just go back a bit. I just did an undo then, and use the constant controller to see if you can get a good feel for what all these various constants mean. So here's A for amplitude. So I'm going to make up and down this bigger and smaller, left and right is the step. So I'm going to make it a bit bigger, so I think it's about right. That's probably it. And then B is the frequency. So it looks like it's just a bit too frequent, so I'm going to reduce that a bit. That's probably about right. And then the phase, well, we want to shunt it to the left, which means we reduce the phase. Always try and get these things the right way around. Notice I've done minus phi because that always means that if phi is positive, it's going to move to the right. So we need to reduce it to move it to the left. And then finally we want to change D, which will shunt the whole thing up. Now, I think that's a very good way of doing it. Now then you finish it off, that and that, right click, Bestfit data. And if you're interested in the actual results, I'm sure you are, select that, text box, there they all are. Get rid of that. Now that's one way to fit data. There is another way, which I should explain. Let's just delete that. If we just select the data, you can do a Bestfit polynomial through it. And you can do up to order 6. Obviously, order 2, 3, 4, 5 aren't going to work, but 6 just might, you never know. And so yes, in fact it's a pretty good fit for a lot of the data. It obviously goes mad over here, there's no way that's going to fit the data, but it is another approach and one worth considering. So there's a quick look at distance, time and Bestfit.